Good morning students, myself Venkatesh, Department of CSE. Today in this class we are going to talk about deadlock concept. Okay. See, in previous class we have studied about memory management and virtual memory. These two concepts are in third unit operating system, and this is also comes under third unit, a third part, that is deadlock. See, in this one we are going to talk about what is a deadlock, what are the necessary conditions for deadlock, deadlock avoidance, deadlock detection, all those things we are going to talk here. Okay. See, before going to see what is a deadlock, let us see some introduction about deadlock. See here, every process needs some resources to complete its execution. However, the resource is granted in a sequential order. The process requests for some resource, and next one is OS grant this resource if it is available, otherwise let the process wait. Okay. The process use it and release on the completion. After completion of that particular resource, the process release that resource. A deadlock is a situation where each of the computer process waits for a resource which is being assigned to some another process. In this situation, none of the process gets executed since the resource it needs is held by some other process which is also waiting for some other resource to be released. Okay. See, let us assume that there are three processes, that is P1, P2, P3. There are three different resources, R1, R2, R3. R1 is assigned to P1, R2 is assigned to P2, and R3 is assigned to P3. After some time, P1 demands for R1, which is being used by P2. P1 halts its execution since it completes without R2. P2 also demand for R3, which is being used by P3. Here process P2 also stops its execution because it can't continue without R3. P3 also demand for R1, which is being used by P1. Therefore, P3 also stops its execution. Okay. In this scenario, a cycle being formed among three processes. None of the process is progressing, and they are all waiting. The computer become unresponsive since all the processes got blocked. A process requests a resource. If the resource are not available at that particular time, the process enters a waiting state. Sometimes a waiting process is never again able to change state because the resource it has requested or held by another waiting process. This situation we can call it as a deadlock. Okay. So majorly in deadlock, none of the processes gets executed. Why? Because since the resource it needs it held by some other process. For example, P1 needs some resource R1. See, the resource R1 is already used by another process. Okay, so it is not like that. Okay, P1 won't get the resource R2 or resource R1. So this situation we can call it as a deadlock. Okay. So next, coming to in deadlock concept, we are going to talk about system models. See, what is meant by system models? A system consists of finite number of resources to be distributed among a number of completing processes. The resources may be partitioned into several types. Each consists of some number of identical instances, CPU cycles, files, and I/O devices, and are some of the examples of resource types. If a system has two CPUs, then the resource type CPU has two instances. Similarly, the resource type printer may have 5 instances. Okay. Whereas coming to this system models, under the normal mode of operation, a process may utilize a resource in only the following sequence. Okay, a process may utilize, if you take a one process, that process may utilize any resource in the following ways. So first one is request, second one is usage, and third one is a release. Okay, so what is meant by request? Okay, for example, if you have process, that process requests some resource. Okay, after requesting the resource, second one is the resource used by the process. Okay, and third one is after using the resource by a particular process, third one is it will release the resource. Okay, request, that means a process request for a resource. After getting the resource, it will use the resource. After using the resource, automatically it will release the resource. Okay, the first one is a request. The process requests the resource. If the request cannot be granted immediately, for example, if the resource is being used by another process, then the request process must wait until it acquires the resource. Why? Because for example, process P1 is requesting R1. That R1 is used by some of the process. What this process P1 should wait? What is the task of process P1? It will wait until it get the resource R1. Okay, that is the request. What is meant by usage? Usage is nothing but the process can operate on the resources. For example, if the resource is a printer, the process can print on the printer. If the resource is a scanner, the process can scan the pages, like that. What is meant by release? After usage, process should release the resource so that another process can use it. It can be done by using the system called like free. In order to release the resource, we are going to use the system calls like free for memory, close for files, release for devices. Okay, all these are the basic three normal mode of operations for a process may utilize the resources. Okay, and next one is deadlock characteristics. So what is meant by deadlock? What are the various characteristics of deadlock? Actually, we can say deadlock is a situation, or it is a condition, or we can say it is a problem. It is a situation when two or more processes sharing the same resource are effectively preventing each other from accessing the resource. Okay, for example, P1, P2 are two processes. Here in this example, P1, P2 are two processes. R1, R2 is the resources. Now P1 is assigning to R1 resource. Here R1 is already allocated to P1, but P1 is requesting for R2 resource. Resource R2 allocated to P2. P2 is requesting for R1. This state we can call it as a deadlock. Okay, this state we can call it as a deadlock. Simply, the technical definition of deadlock is a set of processes is said to be in deadlock situation when every process in the set wait for an event that can only because caused by another process in the set. Okay. For example, if a process is waiting means for a particular resource, that resource was utilized by some of the process. Okay, so this situation we can call it as a deadlock. Okay, see, next coming to what are the major necessary conditions for deadlock. Okay, there are four conditions and deadlock can arises. If four conditions hold simultaneously, then we can call it as a deadlock. Okay, a deadlock situation can arise if the four conditions hold simultaneously in a system. If we take one system, these four conditions can occur simultaneously, then we can call it as a deadlock. First one is a mutual exclusion, second one is hold and wait, third one is no preemption, and the fourth one is a circular wait. Okay, so fourth one is circular wait. We will see one by one what is mutual exclusion, what is hold and wait, like that. See, mutual exclusion. See, what is meant by mutual exclusion? At least in this mutual exclusion, at least one resource must be held in a non-shareable mode. That is, only one process at a time can use the resource. If another process requests that resource, the requesting process must be delayed until the resource has been released. This is nothing but mutual exclusion. Next one is hold and wait. So in this hold and wait concept, as the name implies, that process is already holding a resource and requires some of the additional resources in use by another process. Hence this situation is known as hold and wait. So next one is no preemption. So no preemption means resources cannot be preempted. That is, a resource can be released only voluntarily by the process holding it after that process has completed its task. Okay, for example, the process is utilizing a resource means after completion of the resource of a particular process, then only it will release. Okay, here no preemption, resources cannot be preempted. So in next one is circular wait. See what is meant by circular wait. See a set of processes, that is P1, P2, P3 and so on Pn, of waiting states, waiting processes must exist such that P0, that is P0 is waiting for a resource held by P1, P2, resource held by P1. P1 is waiting for a resource held by P2. P2 is waiting for a resource held by P3, like that. So Pn is resource, Pn is a process waiting for a resource by held by Pn minus 1. Okay, like that. Is a waiting for a resource held by Pn. So here Pn minus 1 is a process waiting for a resource held by Pn. So Pn minus 1 is waiting for Pn, okay, here, and Pn is waiting for a resource held by P0 in a circular manner. Okay, so P0 is waiting for, P0 is a process waiting for a resource held by P1. P1 is waiting for P2. P2 is for P3. P3 is for P4, like that. Pn minus 1 is a process waiting for a resource held by Pn. Again, circular means Pn is waiting for again P1. Okay, so these are the four conditions. These are four conditions that must be true simultaneously for having deadlock to occur. Okay, if system is in the deadlock situation means these four conditions must be held simultaneously. Okay, whenever there is a whenever these four conditions are in a system means, then we can say it is a situation of deadlock. Okay, situation of deadlock. See, next one is next we are going to talk about some differences between deadlock and starvation. Okay, see, starvation is nothing but, we can say, what is a deadlock, what is a starvation. In starvation, we have studied starvation in previous classes. Okay, here deadlock is a situation where no process got blocked and no process proceeds. Starvation is nothing but, starvation is a situation where the low priority process got blocked and high priority process proceed. Next, one more thing is deadlock is a infinite waiting, whereas starvation is a long waiting but no infinite. Every deadlock is always a starvation. Every starvation need not be a deadlock. So these are the some of the differences between starvation and a deadlock. Okay. Next, coming to the concept of methods for handling deadlock. Methods for handling deadlock. So whereas methods for, in these methods for handling deadlock, we are going to ensure that the system will never enter a deadlock state. Allow the system to enter a deadlock state and then recover. If it is deadlock state, we are going to recover the deadlock. Ignore the problem and pretend that deadlock never occur in the system. Used by most of the operating systems like Unix also. There are various methods for handling deadlocks. Okay, so first one is deadlock prevention, next one is deadlock avoidance, next one is deadlock detection and deadlock recovery. So what is meant by deadlock prevention? Deadlock, in this deadlock prevention, deadlock happens only when mutual exclusion, hold and wait, no preemption and a circular wait holds simultaneously. Okay, if it is not, if it is possible to violate one of the four conditions at any time, then the deadlock can never occur in the system. That means among these four conditions, if we violate any one, then there is no chance of deadlock. The idea behind the approach is very simple, that we have to fail one of the four conditions, that is mutual exclusion, no preemption, hold and wait, circular wait. Among these four, we should fail in one condition, then there is no deadlock situation. Okay, but there can be a big argument on its physical implementation in the system. Okay, whereas coming to deadlock avoidance, see what is meant by deadlock. In this deadlock avoidance, the operating system check whether the system is in safe state or in unsafe state at every step which the operating system performs. The process continues until the system is in safe state. Once the system moves to unsafe state, the operating system has to backtrack one step. In simple words, the operating system reviews each allocation so that the allocation does not cause the deadlock in the system. Whereas next, coming to deadlock detection and recovery, this approach lets the processes fall in deadlock and then periodically check whether deadlock occur in the system or not. If it is occur, then it applies some of the recovery methods to the system to get rid of deadlock. Okay, rid means solution to the deadlock. Okay, so this is the deadlock prevention, deadlock avoidance, deadlock detection and recovery briefly. Next, whereas coming to clear information about the deadlock prevention. Okay, just now we have said na, so deadlock prevention, the time when the deadlock occurs, we are trying to find the solution. Better thing is, before the deadlock occurs, we try to find some solution. What are the solutions, that is preventions we can do? The main preventions are the majorly 4 conditions, that is mutual exclusion, no preemption, hold and wait and a circular wait. As we know, these 4 conditions are mandatory conditions, necessary conditions to have deadlock in the system. Deadlock prevention says either try to remove all the 4 conditions from the system, or at least try to remove or discard one of the condition among the 4. If all the 4 conditions are true, then there is a deadlock. But if one of the condition get false, then deadlock will be automatically prevented. Any of the 4 or 4, we try to make it fall. If any one will fall, then deadlock will be prevented. Okay, deadlock prevention simply we are going to try among the 4, we are going to make it false any one, that is either you have to make it false mutual exclusion or no preemption, hold and wait or circular wait, or we have to make it false all the 4 conditions, then we can say there is no deadlock situation. Okay, so if we take mutual exclusion, in this mutual exclusion, whatever the resources we are using, they should be non-shareable. They should not be used at the same time by multiple processes. If it happens, deadlock will not occur. Every resource will be used by one process at a time. If we try to false this condition, the deadlock will be removed. There is problem in mutual exclusion also. Not all the resources can be made as shareable. For example, printer. If we want to remove mutual exclusion, we have to make all resources shareable. It is not possible, that is printer is not shareable. In this situation, in this condition, mutual exclusion is very hard to make it false. If the resource are shareable, then we can avoid mutual exclusion. If the resource are not shareable, we cannot avoid the mutual exclusion. Okay, here in this mutual exclusion, what we are going to see is, if the resource what we are going to take, the resource is shareable, then we are going to avoid the mutual exclusion. If it is not shareable, we are not make it false. Okay, so this is the mutual exclusion. And the next one is no preemption. See, what is meant by no preemption? See, no preemption, if a process is going on, another process is going on, we will try to preempt one of the process. So when the process will be preempted, whatever resources it is holding, it will giving to another process. If the process P1 is preempted, that is it will stop working, it will be sent back to the ready state at the time whenever it holding R1 will be taken back. Then remove P1 because it is preempted. Remove P1, that is it is preempted. P2 has R2 and P2 needs R1. Now R1 is free. If the resource is free, P2 is use R1, then P2 can successfully execute. Process is preempted by using the time quantum method. Process can run for particular time quantum. After that particular time, it will be preempted. when it is preempted the resource of that process is taken back and given to some other process, we are preventing deadlock, making no preemption as preemption. Okay, so if we make the no preemption as prevention, then automatically there is no deadlock. Okay, like that. Next one is hold and wait. So in this hold and wait situation, we are trying to false, that is no hold and wait. Okay, if it is no hold and wait, there is no deadlock. Okay, like that. If the process comes and a process says need 3 resources, before the process gets starts, we will give all the resources to that particular process. Before process started, what is it demanding, we will provide all the resources to to that particular process. Even though very difficult to implement practically, for example, the process needs some of the resources, we are going to give all the process to the particular process, all the resources to the particular process. Require process to request and be allocated all its resources before it being execution, or allow process to request resources only when the process has none. So here low resource utilization, starvation is possible. Okay, this is the hold and wait. So next one is we can say circular wait. Okay, if for deadlock there must be circular wait, but to remove the circular wait, that is to prevent deadlock, there should be a circular wait. We try to remove the condition of, we are going to remove the condition of circular wait from the system. Remove circular wait just giving numbering. For example, here a system having printer, scanner, CPU, register, CPU and register resources, we try to give the numbering to all the resources. That is, when a process requests for a resource, it will request in the increasing order. First one is printer, second one is scanner, third one is CPU, fourth one is resource. If process P1 comes, need resource 1, that is printer, it has taken, then it requests for 3, then it take. Another process P2 comes, it request for 3, it can done, but it cannot request 2 or 1. Why? Because then we can say already used by another process, then we can say no circular wait. Okay, so in this example, process P1 comes, it will request resource 1. Okay, already given for process P1. At the same time, then it requests for 3, it also taken 1 3 already used. Okay, so process P2 comes and it requests for 3. Okay, we have to give the resource 3 to P2, but if it process P2 request 2, we can't give. Why? Because 2 is already utilized by the process P1. Okay, so then we can say no circular wait. Okay, so this is the concept of circular wait. Okay, so in this one we are going to talk about only deadlock prevention. Okay, deadlock prevention means among the 4 conditions we should take one as false, or we can say all the conditions make it false, then there is no deadlock situation. Okay, thank you.